the program sees null, it will identify with every missing value in the cell. So what do we call missing value? Missing value is an empty space in a cell where nothing was recorded in it. So those are the missing values. So by the time you write this code, it will give you the next result, and this is the result you are going to see. So the first one we see that in precipitation, wind underscore chill, wind underscore speed, weather condition, there are missing values in this on these columns. So they show the frequency of the missing value, and the percentage is also written as well. So now I want to plot a graph for visualization so that people could actually understand what this table really means. So I have to write another code to plot the graph of the missing value. So now this is the plot of the missing value. So we can see now that precipitation, wind underscore chill, and wind speed has a very they have a high volume of missing value. So now we need to reduce this missing value. So we have to drop. So that's why we are using the language called drop unwanted columns in the data set. Because if we don't drop those unwanted columns, by the time we'll be running our analysis, it will be giving us some figures that may be out of bounds. So the covered in data analysis, we call it outliers. So in order to avoid having outliers, we have to drop those missing values. So now, looking at it, I said, okay, I want you to drop start underscore lat, start underscore line. So this one means latitude and longitude. I don't need them for anything. So whatever that is there, I want you to drop it. I want you to drop that column for me. I don't want to see the column. And by the time I bring it down, the outcome of the unwanted columns dropped. So in the first column here, okay, I didn't include this because I've actually dropped it. So it shows that I've dropped the missing values. Then the figure here is going to reduce as well. So by the time we also for moving the rows that contains null values as well. So we want to drop all the rows containing null value. So null value is more like in English empty cell, a cell that no value was inside it. So we want to drop those cells. So I have to drop it, use the code drop NA and fix in those columns, which is the start time here, weather condition, weather time strap, like that. So the next thing, I also said I want you to fill the missing values with mean and median. So the column that I want it to be filled, I want precipitation. You know that in our previous data we see that precipitation has a very voluminous number of missing values. So now I now see that in that precipitation now, I want it to be filled up with mean and median values. So when we say mean and median values are just like, okay, figures, probably the mean of something, let's say we pick it at random, 10, 15, and the median could be 5. So it will just put it randomly according to the computer's discretion. So I now say that, okay, give it for precipitation, I want it to be median. Then for wind, I want it to be mean. I want mean values to be included for the wind. Then for the temperature, I need median value. So for the median value now, it could read itself to something dot, maybe 1.2 or like that. So now, after dropping all that, I now see that after cleaning the data set, I want to see a new column, like new column from the previous one. So by the time we check out this new column now, we are not going to be seeing the severity. Now there are some new columns that have been added to it. So on this one, I'm showing that everything is now 0 compared to the other one that we saw a lot of missing values. Like this one now, you can see 231,683 missing values. So by the time you come down now, after writing all those codes, you are now seeing everything is turning to 0, 0, 0, 0, you are not worried that you are seeing, we did not see a new month, start, start time month, new year. That is because we have, like I said from the insight, that those are the new columns that I have added because I needed to solve question 6, 7, 8, and 9. So now, from question 1, it says how many rows and columns have the data set? So now I have two phases here. The first phase is saying that number of rows and columns in the old data set before cleaning, and I have the rows and column of the new data set after cleaning. So you can see the result here now after using the just the short word df dot shape. It will just give me 1,014,575 rows and 52 columns. So in Python, the row comes before the column whenever you see it in bracket like that. Then the new, after cleaning data, we can see 1,024,377 rows and 48 columns as I've explained in the insight. So now number 2, from my explanation, that I said that California, Florida, and Texas are the accident prone states out of the 49. So out of the 49, I have to pick 10 out of it. So I gave their full name, because in the data you will see CA, FL, TX. Because as an analyst, you have to explain it better to people that does not understand all the short codes. So that's how I have to explain it better as California, Florida, Texas, Virginia, New York, like that. So we still have other 49, but for presentation purposes, you have to shorten it. Then now we said in number 2, find out how many states has US. So we can see now that we have the whole data set and the new data set. So if you are going to compare it now, from the old data set, California is 265,613, and from the new data set after cleaning, we have 260,219. So we must have seen the difference of all the missing and errors in it has been erased through the use of those codes. So we have the 10 states that were picked out of the 49 states. Then you now say, right, program, now this is the program for the top 10 accident prone cities, because now we have 49 cities, but we now want to see the top 10. So for us to see the top 10, now this is the code we are going to use. That's when we now have to count it as 10. So we can see where I put on the first row, I stated it as state underscore count 10. That is what I defined it as. Then I now change it to new underscore df. Unlike before, we are saying df, but now I'm using new because I'm using a new data set. I'm not using the old one again. That this time around, though, I want you to read the new data set. The one that I've cleaned is the one I'm using. So now, this is state, the one I want to read, the state. Then value underscore count is for me to count. Okay, I need 10. So if you recognize that I want to count out of the 49, then sort is to sort out the states that I really want to pick out. Then I now put ascending equals to false. So equal colon 10. So this colon 10 now, Python counts from 0, from a starting point is 0, not 1. So it's not going to start from 0 to 10. So to pick the 10 cities. So this is then this one is to, now we are seeing SN. Now, I talked about SNS, which is Seaborn. So now this one is to talk about, I want to plot a graph. So that's when we now start using Seaborn or matplotlib. So now I'm using Seaborn for my graph. So this one now I want to plot the graph of this 10 that I've shown here. So this is the graph of it, showing that California has the most accident prone city, like that. So, and also we gave it a color. I said you should make it white grid. So it will give us then the size of the bar. Maybe I want to this is the size of which I want the bar to look like. Then I also gave it a heading as well. Top 10 accident prone cities in US. That is from this data set. That is plt.x label. That is what I'm using to show that, okay, I want counts to be on the x axis and I want states to be on the y axis by using the plt.y label. Then I want to title it. So I will now use plt.title as that's top 10 accident prone cities. Then by the time you check it, everything is already in place. So that is the beauty of using Python to write your to sketch out your graph.
Point of correction. Go to that graph again. Is it possible to turn it the other way around so that it will be like instead of this horizontal way?
Yes, it's possible, sir.
But why do you choose this approach?
Yes, I did it in two ways.
Okay.
I did the one that you talked about,
Alright.
then I did this one.
Okay.
But from my own view, I actually just love the way it's looking now, because if I use it in the proper way, everybody will be like, Excel can do it like that too. But now I'm saying that I don't want to use it in a proper way, that Python should do what is impossible for Excel to do. And there's still one that Excel cannot do, which is also included in this data that I'm going to show you. So now, I want to see the top 15 most accident prone cities. Like that. So by the time I write this one now, it will give me this result. So this one now, I did it in two ways too. I did it in this format, and also in this one, but I decided to pick this format, then I gave it different colors like that. So now you'll be wondering, how did I give it a color? If you check inside the code, you will see palette. Palette is where I gave it the color. So I now put gist underscore enter. So that gist underscore enter is the color format I want. So by the time you write it, Python will just give you the color that is attached to that code and make it beautiful. So I also said that my x-axis, my y-axis should be accident, and my x-axis should be city, and also give it a title. Then I want to, now the question 5 there is talking about, I want to find out which city are the most accident prone among the accident prone cities. Now the English is too long, so what I'm just talking about is per state per city. So let's see the accident per state per city. So that is now where you saw Miami, Florida in the insight. We saw this other one, Los Angeles, California. So now this is the graph. So you can see now inside this graph, we are seeing on the that is on the y-axis. On the y-axis, we are seeing, like, let's say FL, comma, it will write Miami. So that is just the beauty of what Python will do. That I said that Excel will not be able to do this. So why I said this is because there was a time I was using Excel. Somebody asked me to plot a country. He has many countries. So he wants to look at the year too. So he wants to bring the year and the country together, just like this one. So when I used Excel, it was not giving me the result I wanted. Everything was choked together. But looking at it now from Python now, Python was able to reduce it to the number of states I want to see, and brought everything together looking beautiful and nice as well. So you may wonder that why am I making this slant like this as well? You can equally see turn up as well. But I just chose to pick this style. So in order not to bombard the whole slide, so I have to pick one and not to confuse people. Then now, which hour of the day has most occurrence of accidents? So this is the code. So now we are now seeing that the time start time hour is what I'm using as my to identify with what is in the column of that Excel sheet. Then I want it to give me a color. So in the project I choose PRGN. Now it's different from the other one that I use the other code for the color. So by the time we run it down, and I'm using both Seaborn and a Matplotlib to bring it together, and I said I want it to be histogram like that. So this is the histogram format of the hour of the day. This is the frequency by this. This is the frequency by this side, and this is the hour of the day, and this is the title, and this is the histogram. So now looking at it from the inside, I said what you'll be saying is from 0 to 20, which is in the general time. So that's why I could say, okay, this 0 is 12 a.m. and looking at it around here is 2 p.m. So showing that from 12 to 2 p.m. has a very that's the most occurrence of accidents in US. Then also the other one is within this time, this frame, this is the second peak around here as well. So I have to pick it from this range to this range. So this range we'll be talking about that's 17 as well. So 17, these are around this is that's 15, 17. So something somewhere around here is 13 to 17. So that's around 2 p.m. That's around 2 p.m. here to 5 p.m. for the general time. So which day of the week has the most occurrence of accidents? So this is also the code to bring out this result. So I changed the color. You know, the color we have here before is purple, but I said no, I want it to be green color. So now we have Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. So these are the days of the week. So we can see now that Saturday is having the highest out of all the days. But if you look at the days generally, there's no variation among them. So when we talk about variation, there's no really significant difference like that. But on Saturday, it shows that difference. But on Sunday, the incidence of accident was very low on Sunday. Probably on Sunday, most people rest at home. They go to church, they return back home, some don't go to church at all. So that's why Sunday looks like that. Then I have which year has the most occurrence of accidents. So now talking about the year, so I said I want to make use of count plot. So now count plot is giving me the figure on each of the bar. So in the inside, I said 2021 as is the deadliest year. That is having the highest occurrence of incidents of accidents in the US. While 2020 is very so we can see now what the results are giving us. So we can see from 2016 is dropping down. Then in 2021 it increased like that. So then the interpretation is that the year which has the most occurrence of accidents, I see that number of accidents were decreasing more significantly. The change in the decrease from year 2016 as compared with those in 2017, 18, 19, 20 were reduced in the year 2021. So the number of accidents increased drastically. So therefore, the year which has the most occurrence of accidents is year 2021, as we can see here. So now, question 9, which month of the year has the most occurrence of accidents? So now we can see it on the table that we have February, March, April, May, August, July. So this is the occurrence of accidents. We are seeing in February 16,404 like that. So now we want to see the one that has the highest among all these months that has the incidence of accidents. So now this graph is now showing that January and December is having the highest. So January has the highest as explained earlier. We have December and this is November. So it's more like if you look at it, it looks like a bell shape. It looks more like a bell shape. Like a bell shape. So we can see that it is normally distributed. If we are going to talk about normal distribution, that the occurrence of accidents is normally distributed because it has a bell shape like that. So then number 10, what weather condition do the vast majority of accidents occur? So this is the code for this. So in this one now we want to see the weather condition. So now we are bringing temperature and weather condition together. Then we are talking about the severity as well. So severity is just to show the level, that's the occurrence of the temperature, because that one is like a kind of ranking from 1, 2, 3, 4 like that. So now this is the output of the weather condition. So it's showing that we have fair, we have most cloudy, we have cloudy, partly cloudy, clear weather. Even in clear weather, we still have accidents occurring as that's in clear weather we have 81,205, being the that is 1 2 3 4 5 fifth vast majority of accidents occurring in US. So even in clear weather, people are still having accidents, not to talk of when the weather is not fair at all or the weather is cloudy. So now, for people to not understand and see clearly, so we now have to bring it to the graph that okay, we want to use a subplot. So now this is the subplot. Also, this one too, this graph can be turned other way around, whereby this pair will go up rather than coming in this slant way. So from this one, why I use this format is because it is showing clearly how long the data looks, that the result of the incidence of accident in the fair weather condition, the most cloudy condition, and the cloudy condition. So we can see now that this one is skewed. That's when we talk about skewness. So this one is, if I'm going to turn it other way around, so it's going to skew to the right as well. So then, and that's it from my analysis. That is the summary of everything, which is talking about the last question, that what do I think could be responsible for majority causes of road accident and how to prevent the accident. So now the first one is majority causes of the accident. So we have to know what is causing the accident first. Number one, over speeding. We have driving while drunk. Some people like driving while drunk. Then driving being distracted. Some people will be distracted pressing their phone. Maybe some babies are playing behind, fighting. Instead of you cautioning them, or either you park and caution them, or if there's somebody behind them, you with them, tell the person to caution them. Some people will see angrily want to be looking at the back and correcting them, which would cause a very fatal accident. Then drive without you are driving without your seat belt is also not good at all. Then there's a traffic light. You have seen the red light, you are still driving past it on the T junction. So any vehicle from the green light may be coming and it just hit the other vehicle that is innocently following the order of the light. Then avoiding safety gears like wearing of seat belts. You are using a motorcycle, you are not using your helmet. So those are the safety precautions you have to take into consideration. Then overloading of vehicles. People will just load their vehicle to the point that the vehicle will never be able to move, and they will still overload it like that, not even caring that the tire could burst. Then how can we prevent this accident? So I said educating mobile drivers and like giving them awareness about road safety and precautions, making them know the signs. Where this one is saying that 40 kilometers here, they should obey the 40 kilometers. Whenever they see load, which means that there are heavy vehicles passing, so they have to reduce their speed. Like that, then strict enforcement of the law by the agencies in charge of the road safety. So they have to ensure that all the road safety, the police forces on the road have to ensure that they are enforcing the law and not violating it themselves. Then also having good road network and maintenance, because we can see in Nigeria we don't have good roads. But outside the country that they even have good roads, probably during this accident period, the snow must have covered the road and drivers may not be able to have a clear view. So they should employ people that would clean the snows for easy access and put precautions for them to see that okay, you cannot drive past this range like that. Then car maintenance and servicing at the right time. Before you start your car, check your oil, engine oil, check your gear oil, check your brake oil, check the water of the radiator, check your power steering oil, check your tires, be sure that the bolts are well left before you move. And also the battery of your car, be sure that the battery is well clean, because if the battery goes off, it can also cause a spark and it cause a turn to the vehicle. Then full concentration while driving, observing and obeying road signals and traffic lights to be sure that you are not pressing your phone when you are driving. Obey all traffic lights and the lights. So we don't learn from talking, we learn from this. Thank you.